Well, good morning. Does that sound all right, or is it too loud? Okay. When I teach my classes at noon, I never know whether to say good morning or good afternoon, so technically it's afternoon. First of all, let me thank Jana for inviting me to come today and talk about a subject that is a passion of mine. And I think this whole historic lecture series is phenomenal. We've been doing this we've been coming up here for probably 35, 40 years, and this has always been a highlight of every week we're here, so I really enjoy that. How many of you are from Colorado? Raise your hand. Okay. So some of you have experienced this climate change issue yourself personally, and we're going to talk about some of the things going on today. I was interested in the Daily announcing the lecture today. It's the title they gave was Climate Conundrum, Adapt or Migrate. And I thought, I wonder where we're migrating to. It really was mitigate, but we actually may look at migration as an option. The other thing I want to note is I am an environmental lawyer, and I have practiced for over 45 years. But my real passion is education, and I've been teaching as an adjunct professor for 42 years at the University of Denver, in the law school and the business school and various places. But I'm not an expert on climate change, so I'm sure there will be some questions afterwards you'll be asking me that I won't be able to answer, but I'll do the best job I can. And then finally, just mention that whenever you don't know your audience very well, you have to kind of assume that you're going to shoot for somewhere in the middle. So there'll be a little bit of basic stuff in this, and hopefully some new material that will help you understand what our problems and what we're dealing with. Okay, so figure out how to run this system. Jana, I'm pressing down on this. Oh, that's the block one. Let's see.
The right arrow.
Well, I'm pressing there we are. Okay. So when I got the invitation to come up here, I started early, as I usually do. And this is what it looked outside in front of my house. And I thought, how am I going to, in the world, talk about global warming? And of course, that also raises a question about how we define the terms in which we talk about climate change. And I also enjoyed this particular political cartoon about the summer forecast for Olympics, when it's really about a lot of things going on that we're already experiencing. Okay, there are a lot of things I could talk about, and that's one of the problems with a professor, is that you want to try to cover everything. And I started out putting together a PowerPoint, as I said, about 5 months ago, and I think I was up to about an hour and a half. And so the tough part was to whittle it down so that you guys don't fall asleep or leave before it's over. So I'm hoping that my selection of things to talk about will at least touch on a lot of these. So we're going to talk a little bit about what is climate change, what are some of the causes, what are the consequences of it, options to address climate change, a little bit about international collaboration, and then a few final thoughts of mine about where we are and my concern about my grandkids and the life they will be living. All right, what is climate change? Well, this is sort of the first basic slide of the difference between weather and climate. Weather, of course, is very short, and it's diurnal. It changes, we say every 24 hours, but it really changes oftentimes in Colorado every 2 hours. So it's something that we see is very episodic, it's very temporary. Well, on the other hand, climate is something we view in long term, at least on an annual or biannual or even decade basis, to see what's actually happening in terms of the climate. So a very simple explanation, of course, is that we have this Earth here, which spews certain chemicals into the atmosphere, carbon dioxide, and water vapor, also methane, are some of the pollutants that go into the Earth. And what happens then is that as sunlight comes in, radiation comes in, it is actually trapped inside. So it becomes kind of a barrier to a lot of that heat that is coming from the sun escaping, and that's what warms the Earth and what we call global warming. So over 20 years, methane will trap about 80 times as much heat as CO2. And we'll talk about that a little bit later. But we have two pollutants that we really are concerned about, carbon dioxide and methane. All right, so our methane sources, just as a matter of understanding, come from these different places. Everything livestock, oil and gas, coal mining, and I'll talk a little bit about the oil and gas side a little bit later. But those are the sources that we really have to target when we think about what do we do to mitigate the impact of these particular pollutants. All right, I was told not to be terribly political in this talk, and that'll be hard for me to do. But I do want to give you a bit of a historic line of what we've been talking about in terms of climate. So it really starts back here in 1825 when a French physicist and mathematician by the name of Joseph Fourier discovered that the atmosphere really controls the Earth's temperature. That is, just the natural water vapor in the air surrounding the Earth traps some of that heat. And in fact, the Earth would be a lot colder if it weren't for that particular phenomenon. Then in 1859, this was an Irish physicist by the name of John Tyndall, who discovered that CO2 and water vapor absorbs that infrared around the Earth. And of course, that's what maintains some of that heating in the system. Then jumping way ahead here, a lot of other things happened, but jumping to 1953 is really when we started measuring the correlation between the amount of carbon dioxide in the atmosphere and the temperature change that we see in a long-term basis. 1965 is really when I think our country began to recognize that there was an issue here that needed to be addressed. And I remember the National Academy of Sciences did a report roughly around this time, and they identified climate change as a possible thing that we needed to be concerned about and that the Earth's temperature was warming. But it wasn't until 1988 when James Holmes, who is a physicist, he is also the head of the Goddard Institute for Space Study. Sorry?
James Hansen?
James Hansen.
Yeah.
What did I say?
Holmes.
Oh, I'm sorry. That was my orthopedic surgeon. It was. James Hansen testified before the United States Senate about the problem of potential disastrous effects of global change, of global warming that might occur. So we've known about this problem a long time, as I just mentioned, and of course the oil and gas industry did too. This was an article in the Scientific American back in 2015 that said Exxon knew about this change for almost 40 years. In fact, a lot of people did, but weren't willing to recognize it or do anything about it. In fact, to the opposite, they actually published these things in newspapers trying to discount or discredit the idea that global change was a problem. And here are a couple of, they formed a group called the Citizens for the Environment in 1991, which was really their front for raising money for these kinds of advertisements. So how do we know what the future is likely to be? Well, we do something called modeling. And modeling is a way in which we can use very complex computers. And scientists divide the Earth up in, as you see, into these 54 interactive grids, three-dimensional grids with 54 interactive variables per grid to actually calculate what's going on. And over here shows what are some of the examples. I don't know if you can read that, probably not very well. But it's everything from atmosphere and humidity to amount of radiation coming in, cloud cover. All of those factors go into this kind of a calculation. One of the first jobs I had when I came to Colorado was to work at the National Center for Atmospheric Research in Boulder, which happens to be probably one of the most outstanding research institutions in the world. And we were studying climate change back in 1980 when I was there. And the model we had was one of the first Cray computers. But we've come a long way. A typical climate model today includes about 18,000 pages of printed text or 500,000 lines of code. So we need some very powerful computers to make these kinds of modeling runs. United Kingdom, at their meteorological office, happened to have just that. Their new Cray XC40 supercomputers are capable of 14,000 trillion, and I don't know what that number is, calculations a second in order for us to be able to give us 215 billion daily weather observations from all over the world. So, I mean, just that's hard to imagine how much power it takes in order to do the kind of modeling that we're doing with climate change. Here's a very simple example of a forecast modeled scenario. This, by the way, this red line is roughly where we are today. This is 1.2 degrees centigrade above pre-industrial levels, and I'll tell you what pre-industrial levels are in a little bit. But as you can see, here's where we are today, right at, you might say, the crossroads of this. And here's a low scenario for doing a lot of what we're going to have to need to do to stay under the international goal, which I'll talk about later, which is 2 degrees centigrade. But intermediate means we do a little bit, and obviously very high suggests that we don't do anything at all about climate change. All right, so we not only model it, but we also measure it. And our measurements here, this happens to be from the Mauna Loa Observatory in Hawaii, where we have seen since 1960 to roughly 2020 an increase in the atmosphere of CO2. So we're currently at the level of 424. You remember that number because that's a key number in looking at what is the concentration of carbon dioxide in the atmosphere. If we look over here at this example, we see again that CO2 trend, but we also see the variable temperature trend, which again is on the rise. So maybe we don't need any physical evidence, but clearly if you live in Colorado or the West, you've seen it. Everything from droughts to the Colorado River being seriously depleted. And we have seen a global surface temperature change. And a lot of these numbers, it says reconstructed. We actually have gone back thousands of years using ice samples that's collected at the Antarctic and other places to calculate how much CO2 was in the atmosphere at that time. And you can see about starting in 1850 how we have seen almost an enormous increase in the number, in the amount of CO2, or I'm sorry, this is a change in temperature, change in temperature. And that 1850 to 2020 is that key period of really before 1850 is that pre-industrial level. If I go back here for just a second and just look at this, this is a blow up of that again. And you can see how from year to year it may change, but what we're really looking at is the trend that's being created by the temperature change. So since 1800 to 2020, we've actually seen the atmosphere increase by about 1.96 degrees Fahrenheit or 1.09 degrees centigrade. And likewise, on land, it's been a little bit more because, of course, land absorbs and holds the heat. On the other hand, the air tends to allow it to escape. I might say that this past Sunday, it was just reported that it was the hottest daily average global day in 84 years. So I try to keep up with this, but it's difficult. There's so much information. All right, so yet we have skeptics. And this was a Pew Research Center poll done just last August. It says a majority of US adults describe climate change as a major threat to the country's well-being, but it's a lower priority than issues such as strengthening the economy and reducing healthcare costs. Now, why do you suppose that is? Well, we know why it is, because things that are off in the future are very difficult to get too excited about. But on the other hand, when you worry about the cost of groceries going up or the cost of medical facilities, it's a whole different issue. Here is that graph showing all US adults, and unfortunately, we do see that a lot of the people who are not concerned about it tend to be more lean towards a Republican, and Democrats tend to be more. And that's, you're going to see, I think, is an issue in this election, unfortunately. When you talk about the Project 2025, which is a Heritage Foundation proposal to cut all of the climate funding and research that we're doing today. Overall, just less than half of the Americans say human activity is the primary reason. By the way, that number used to be in the low 20s just a couple of years ago. And the Earth, by contrast, 26% say warming is mostly caused by natural patterns, and then 14% unfortunately don't believe that climate change is even an issue. But here's proof. So this is something tangible that people can point to if they don't want to believe the science. All right, so what are some of the causes of climate change? Well, man-made sources of greenhouse gas emissions, obviously, are fossil fuels, which is the really big one, agriculture, mining, industrial processes, and deforestation. Now, deforestation also causes the kind of production of methane because of the deterioration of the vegetation, but it also is a double whammy because all those trees we cut down absorb a lot of that problem and helps us. If we look at just human causes of climate change, here's a graph over here showing sources. Now I'm going to talk about the source of this a little bit later, which is the International Panel on Climate Change. This is their 2021 report, which kind of breaks down by sector where a lot of the emissions are coming from. So you can see it's pretty well divided between industry, residential, commercial, transportation, and agriculture, okay? If we look at energy-related emissions by sector, we can see, again, this is from the US Congressional Budget Office, that in the past, particularly in the early part of this century, a lot of it came from electrical production, but we're seeing that change very quickly. As more coal-fired power plants are being decommissioned, we see more of the type of solar panel fields that are being built, which are very competitive, and, if not much better in terms of burning coal. Transportation is still a problem. We're seeing EVs help a little bit, but they're very, very minor right now. They're much better in Europe than they are in our own country. And then industrial, residential, and commercial are down below. Now, if we look at CO2 emissions of fossil energy and industrial sources by country, because climate change is not a US problem, it's a global problem, and the US contributes to it, of course. You can see this is a snapshot in 2022 where China is. Or US, which contributes about 14% of the global CO2 emissions. China is contributing about 30% because 53% of their energy production still comes from coal-fired power plants. Although China is making some significant steps. Today, two-thirds of the large wind and solar farms in the globe, globally, are in China. So they are really making an effort to try to produce some renewable energy for their systems. They also installed last year more solar panels than we have in our entire history in the United States. And finally, they put a ban on permits for steel mills that use coal. So those are some pretty significant steps, but they are still a major contributor. If we look at it over time, historically, you can see, however, that the US from 1750 to 2022 is still the major contributor of CO2 to the atmosphere. All right, so what are the consequences? Well, the consequences are, number one, extreme heat. And we know that heat has already killed about 4 million people globally since 2000. Forest fires, all we have to do is look outside today and see the impact of what apparently we're told are forest fires from Canada or Northern California. Drought, malnutrition. Global heat deaths are projected to increase by 370% if actions not taken to limit the effects of global warming. Now, that assumes we are doing nothing, so that's why that number is so large. But an additional 550 or 525 million people are also expected to experience food insecurity, aggravating the global risk of malnutrition. Sea level rise from melting glaciers. Some of you, I'm sure, have seen that picture in the top left of what's happening to our glaciers. this global sea level is a chart of the change that we have seen in sea level. And the average, global average sea level has risen 8 to 9 inches in the last 150 years. But probably more significantly, in 2022, the global sea level set a new record high of 4 inches above 1993. That's just in 30 years. We've seen almost half of what we saw in 150 years. So these we just finished a cruise along Alaska's coast. We saw the Hubbard Glacier and the Mendenhall Glacier. This was one of the short little videos they had in their room, and I tried to record it just to give you an idea of how they have seen the glacier retreating over time. This is another picture of it. And this just over the last 20 years, we've seen this. And if you ever see a map of that part of Alaska, Juneau and Sitka and Segway, you see almost this entire glacial sheet up there. And there are pictures of that actually seeing the recession of ice from that area. So 52% of Americans live in coastal counties. 40% live on the shoreline. And as you can see from this picture, this is what they are anticipating will be the incursion of seawater as the sea levels rise. Another picture of the same thing. If we were to see all the glaciers and ice sheets melt, and we don't know when that's going to be, and its estimates are 50 to 150 years. But that's the time frame we need to be concerned about. That's going to be our great-grandchildren, hopefully, are still living here. It's going to rise 200 feet. It's going to take a lot of land away, which is where most Americans are living today. In addition, a third of our World Heritage, 50 World Heritage sites are already condemned to disappear by 2050. I love this picture. These are historic water level trends in Sandy Hook, New Jersey. You can see in the past 80 years, sea level's risen about a foot. We expect in the next 40 years, it may go up another foot. Pretty soon, we're going to have a lot of problems in Manhattan, among other places. A lot of waterfront property for sale. So Manhattan lies between 3 to 6 feet above sea level. So you can imagine before we even get to 200 feet above sea level or 200 feet rise, we're going to see some problems. Extreme weather, okay? Research says all the risks from these extreme weather events will escalate as the planet warms. Tornadoes, for example, we saw 400 tornadoes cited in April, twice the number from last year. 1,250 tornadoes reported already this year, which is the same number that we had for a full year last year. By the way, we went to see Twisters last night. It was pretty scary. Weather disasters in North America cost $450 billion in 3 years, 2/3 of the world's total. Taxpayers are paying 10 times more today for disaster relief than to compared 30 years ago. I took this particular chart out of, write the source down, Atlantic Hurricane Season Forecast. You can see for 2023, they named 19 storms. They're anticipating 20 to 25, 8 to 12 hurricanes versus 7 from last year. Major hurricanes, 4 to 7. And over the 30-year average, we're going to see some major changes, 2 times as bad than what we've seen in the past. If we want to look at the economic loss of this, you're wondering why your insurance rates are going up, depending on where you live, either from forest fires or from water incursion or whatever the case may be. This happens to be looking in 10-year increments at what's happened. And this is globally, okay? So this isn't just the US. But as you can see here, in looking at globally what's happened, we've seen about a 50% increase over the 10-year decade or the decade before, okay? Colorado insurance rates have increased 30% in the last 4 years. And again, just to give an example, in the first 4 months of 2024, we've seen roughly $14 billion worth of disaster costs from various activities. And you can see primarily from storms, and probably 70 deaths attributed to it already. So we did have a group for a long time. Unfortunately, they went out of business, but it was called the Rocky Mountain Climate Organization, and it was looking just at what's going on in the West. So some of this is a little bit older material, but they did a number of reports that I thought were worth mentioning. One is the conclusion that they reached that hotter and drier ecosystems are happening primarily in the West. And the impacts of that, again, from that International Panel for Climate Change, which I'll touch on again later, in their last assessment, they said climate change in the Western mountains by 2100, which is like, 75 years from now, we'll see decreases in snowpack, more winter rain events, increased winter floods, reduced river flows, more intense and longer droughts, and more heat waves. So more specifically, in the West, 21 climate models have projected somewhere between a 4 to 10 degree rise in the next 80 years. The impact, of course, will be, again, the same types of things: more rain, less snow, snow melts earlier in the season, and higher rates of evaporation. We may, in fact, find a new sport here called rock skiing. In fact, Aspen, when they saw the initial reports on the impacts on the West, their own study showed that they'd have 10 days shorter by 2030. That's just 5 years from now. 2100, 4 to 10 weeks. They put this advertisement in the paper to try to raise awareness of what's going on with climate change. They called snow the new endangered species. Wildfires. Again, we don't have to be reminded of the threat of wildfires, but in the 17-year period that they looked at between 1988 and 2005, compared to the previous 17 years, there was almost an 80-day increase in the fire season, 4 times as many fires, 5 times as long to put out a typical fire, and 6.5 times as much acreage burned. Disruption of our ecosystems, for those of you who are fishermen, or fisher persons, I should say. We're seeing a significant reduction in Western trout populations projected by 2050, 20 to 40% in Pacific Northwest salmon. Even some of our species that may be endangered from extinction are things like the ptarmigan. You can say it, I can't. At the Rocky Mountain National Park. Desert bighorn sheep in the Death Valley and a few of our other national parks and reserves. And even the grizzly in Yellowstone National Park. And I like this when I was in Washington recently, and there's a big story there about Stumpy. Does anybody know about Stumpy? He is one of the cherry trees on the tidal basin in Washington, D.C., that because of the low water levels and the high amounts of salt water coming into the system, it's killing a lot of the cherry trees around. So they now have, you can buy a t-shirt with Stumpy on it, just to remind you. All right, possible solutions. Well, there are 2 options to address climate change, and I started with that. One of them is adaptation, which really means prepare to live with it, okay? And we'll talk about some of these things. And then there's mitigation, which is doing things to try to reduce the impact. And I guess after your article, or this would be do something about it. And then after the daily article I had in here, migrate to Mars, which at least one of our billionaires is suggesting will be the future of our planet. We'll just let Earth go, move somewhere else. Not typical, or very typical of a lot of our mentality in the past. So there's a lot of overlapping kinds of strategies that are both adaptation and mitigation. Some of them are just things like planting urban forests and some of these things that I will talk about a little bit later. This is the new Western homestead. That's when sea levels reach 200 feet in Iowa. Anyway, when all the ice melts, as I mentioned, we're going to see that 200 feet high level. And this happens to be what Venice might look like. You can see the red area as the incursion into land. And Venice is already taking steps to do something about that. And this is a short video that will describe it.
Italy is in peril. Models suggest the sea level here could rise more than 40 inches by the end of the century. It would seem the future of this remarkable city is bleak. But now there is hope. After nearly 20 years of construction and some $8 billion, a network of enormous flood barriers called the Mose is in place. It is designed to block the floodwaters before they reach the city. The scale of this project is immense. 78 individual gates are arranged in 4 barriers that each stretch over 1,100 feet across the inlets to the lagoon. So the barriers are only lifted when a flood endangers Venice. Each gate is colossal, approximately the size of 2 tennis courts.
These gates are fixed. Then they join together and hold back the high tide.
Most floods last fewer than 4 hours. So once the threat has passed, the team can lower the barriers.
So you can see this one example, if you will, of what one country or one community is doing to try to deal as an adaptation to, actually a mitigation. It's an adaptation and a mitigation in terms of rising sea levels. But this is not unusual. We already have something called the Ike Dike that Texas is proposing to build along its coastline that costs something in the order of $50 billion is what they're projecting. Miami is considering a 20-foot seawall across the Biscayne Bay. And Charleston, South Carolina has already earmarked $1 billion for an 8-mile-long seawall. So we're going to see these coastal communities. If you're in one, you may see that these kinds of plans are being contemplated. I like this as a better solution to Venice from the earth sinking. This happens to be Hands, which is a masterpiece by this Lorenzo Quinn that's also in Venice. Agriculture, we know that agriculture is a third of the human-caused kinds of pollutants that we're dealing with. And what are we trying to do here? Well, we're trying to build healthier, spongier soils and increase soils. Make farms, redesigning them as making more diverse agro systems, incorporating trees and native perennials, reducing dependence on fertilizers, and developing new crop species, livestock breeds, and farm practices. Interestingly enough, my research has said most of this work is going on in Africa today, and we're learning from what they're doing in terms particularly of new seed types that can exist in very hot climates. We do know residential and commercial buildings are still a major part, 40% of our energy consumption. You know, we've talked about for years that simply adding more insulation, doing double pane windows, making sure your doors don't leak are the probably most significant thing you can do to reduce the amount of energy that your residential units use, or your commercial units for that matter as well. So that is, by the way, better insulation using tax credits and rebates that are available today. Natural flood control. About 75% of Louisiana's coastal wetlands are drowning, could be drowning by 2070. And so the National Oceanic and Atmospheric Administration is putting a lot of money into doing wetland restoration projects, trying to preserve more than 12,500 acres of this coastline. Employing natural solutions. These are called biophilic cities, which I found interesting, where we're using more greenery to try to reduce the amount of heat absorption we have in our central cities. And if you look at a map, as you can on the left, you see where the heat rises obviously in areas where there's lots of concrete, blacktop that absorbs that heat, while in the residential and natural areas that heat is not as high. So creating urban forests to reduce the heat islands and absorb the CO2 is a strategy. Denver's planted more than 250 to 500,000 trees since 2006. And we know trees absorb and store CO2, and they create shade to cool the area, release water through the leaves, and absorb water, reducing floods. All right, I want to move from some of the more natural things, if you will, to the technical fix ideas. And there are a lot of them, and I'm not going to cover them all. But I picked three that I thought I might mention. One is carbon capture that we see today, use of hydrogen as an alternative fuel, and something called solar shields. So carbon capture is relatively new. In the last 10 years, we've seen a number of facilities. This one happens to be in the Arctic part of Iceland, where they put together their first CO2 capture storage facility. And it only captures 50 tons of CO2 per year, which they mix with water and then inject underground. They built a second version of this, which is called Climeworks, which now collects 10 times that amount. And they use these large fans essentially to pull the air in, filter it through, take the carbon monoxide out, or carbon dioxide out. And then they use that carbon dioxide by putting it into greenhouses to actually create an environment for growing vegetables and plants. The bad news is worldwide, we emit 39 billion tons. So you can imagine carbon capture, we'd need an awful lot of those plants to make any difference. Use of hydrogen as a fuel, and this has been around a very long time as well. Fuel cells now are being used in buses in various parts of the country. We now have an automobile that will run on hydrogen, and even aircraft that run on hydrogen. Fortunately, hydrogen is a plentiful atom. It's very versatile. It produces emissions. It produces only water emissions at the point of use. But we have a lot of different sources of it. And unfortunately, a lot of the sources today are what we call gray, or gray hydrogen, brown, turquoise, blue, which comes from fossil fuels. So it doesn't help to burn fossil fuels or dig up fossil fuels to build hydrogen. The ones we really are interested in are green hydrogen, where we can use renewable energy, solar energy, to actually split the water molecule to get the hydrogen. So those are not really viable. The advantages, again, plentiful source, cars function on it, similar to EVs. The only emissions water, it refills quickly and provides a greater driving range. But unfortunately, the downsides, I think, outweigh it. And it's a massive cost to build the infrastructure to support it. And we see that now, even with putting in charging stations for our electric vehicles today, is a big challenge. Cost of making the fuel cells is expensive. It consumes 3 times the amount of energy per mile. 95% of it's produced from fossil energy. And electrolysis, which is the green energy side, is really still too expensive today. So it's not much of an option in terms of future for transport. I think this is the one that I find most interesting, and it is solar shielding. And the scientists have calculated that if less than 2% of the sun's radiation is blocked, that would be enough to cool the planet by 1.5 degrees centigrade. Well, how would you do that? Well, the options are you build a giant reflective sunshade constructed in space between Earth and the sun. This would be sort of an example of that. You might mine dust from the moon and shoot it into space, and that particles would create kind of a shade. Or you use marine brightening, and I'll show you an example of that in a minute, which is actually being tested by spraying salt water into the clouds above to reflect a lot of that sunlight. And here's that example. This carrier down below here is actually using that particular technique near Alaska, where their exhaust emissions from the ships brighten the clouds. It's called the Tomy effect, and actually reduce the amount of radiation reaching Earth. Solar shielding increases the reflectivity of buildings in order to reduce their absorption. So we create an ocean mirror by churning up millions of tiny micro bubbles on the ocean surface to reflect the sunlight back. Or by removing cirrus clouds from the atmosphere, which absorb large amounts of long-wave radiation, providing a balance that warm the planet. So, I mean, this really is an example of reducing the albedo, if you will, in places on Earth, again, buildings that would help reflect that sunlight. But we still need a lot of solar geoengineering ideas to get much use out of any of these. All right, I want to switch for just a moment and talk about, I mentioned already, this is a global issue. So we need a global approach to it. And we have some international cooperation that is, of course, going on. And it started in 2015, where the UN's framework on climate change adopted certain objectives and principles to prevent dangerous interference, to prevent, minimize the causes of it, and comment but differentiating responsibilities. And as you can see, there's no teeth in this. These are all goals, the things to try to get people educated and aware of the problem and start to do something about it. We followed that with something called the Kyoto Protocol. You may remember that name, which was negotiated in 1995. It actually was the first time that it included some quantified emission reduction targets for developed countries, and didn't address developing countries, because we historically and presently, most of that comes from developed countries. It proposed to begin in 2008 and end in 2012, but unfortunately it was never submitted to the US Senate for ratification. It was repudiated by the US in February of 2001 and abandoned by other major countries like Japan, Russia, New Zealand. So it was a failure in terms of trying to move forward with international. Now this is the latest and perhaps the most successful, the 2016 Paris Agreement. Again, its aim was just to educate leaders of various countries about the problem and understanding that the risk of fossil fuel-driven climate change. And as of February of last year, 194 states and the EU, representing 98% of the greenhouse gas emissions, have ratified the agreement, including China and the United States. In the Paris Climate Agreement, almost 200 nations agreed to keep the global average temperature from exceeding 2 degrees above industrial levels, and to pursue efforts to keep below 1.5. So the question is, what are the pre-industrial levels? Well, it is that period between 1850 and 1900 where we started to see this sort of geometric growth in the amount of greenhouse gases being emitted, which came obviously from the burning of fossil fuels. Today, we are approximately 1.2 above that pre-industrial level. That's those 424 parts per million of CO2 that I mentioned earlier. And you can see here, this is some examples of looking at it in terms of greenhouse gas emissions and then temperature changes and so forth. Just want to touch on that. I don't want to get into this too deep, but I want to mention that this Paris Agreement, which was negotiated back and mentioned it, set 1.5 and 2 degrees centigrade as the goals. And it communicated its to new and updated what are called national determination contributions. That is, they tried to say for major countries like China and US, India, countries that are major contributors, to try to set some goals specifically for them. Then they had a check as to what kind of progress they were making last year. It was called the global stock take. And here was the results of that. Not as encouraging and as positive as you would like. So we have this thing which is the real scientific underpinning for climate change, something called the Intergovernmental Panel on Climate Change. And it was created in 1988 as part of the United Nations Environmental Program. And it's comprised of 195 member countries, almost 782 scientists, and hundreds more contributing authors who've analyzed more than 66,000 peer-reviewed studies to the reports that they are now issuing annually. And these are ones that help countries make decisions about where they're going. These are some of the front covers of examples of what we've seen in 21, 22, and 23. And if you're interested more in this issue, these are excellent resources for you to take a look at. So just being totally unequivocal about this conclusion was the 2021, that it is no question but that the warmed atmosphere, ocean, and land has changed in the biosphere and is influenced by the kinds of change that we're looking at today. So for a moment, federal actions. Infrastructure Investment and Jobs Act of 2021 provided some guidance on funding for carbon emission reductions in transportation-related sectors. Mostly, again, this was grants, it was encouragement, but it was not enforceable regulations. Then we had the more recent Inflation Reduction Act, which provided 70 different types of investment and types of credits, almost $400 billion. And I might mention, it was just in the paper the other day, that $4.3 billion of this was actually given to EPA, of which I think the state of Colorado just received $380 million to do, particularly aimed at methane reduction in the gas and oil industry. So EPA is required to work with the states. I guess I put it in here. EPA just awarded $328 million to address climate change, methane in particular. Under existing law, I worked for the United States House of Representatives for 6 years as professional staff in a renewable energy subcommittee. And just prior to that time, we passed the Clean Air Act in 1970, which was probably the most powerful and probably the most effective law we've had in reducing emissions. And EPA took the position that climate change, CO2, was a pollutant and should be and could be regulated under the Clean Air Act. And of course, this was affirmed by the United States Supreme Court in 2007. And then we have today, which I think is interesting, some of you probably read about this, a group of youths in Montana who read their constitution in Montana that guaranteed them a healthful environment, have sued the state for the what's called the Montana Environmental Protection Act, which actually discounted the use of climate change as one of the things that should be considered. And they've sued, and so far the lower court has supported them. And obviously this is going to be and has been appealed to the United States Supreme Court. And we might guess what might going to happen there. So what's the most effective approach? And this is really the last thing I'm going to mention to you guys, and I want some questions from you afterwards. But the question is, do we use the carrot or the stick? And the answer is we use both. And there's no question that adaptation and mitigation are required, and we are doing both. Carbon pricing is the most effective tool. Economists and policymakers consider carbon pricing one of the best tools to combat climate change. So what's involved in that? There are really two different approaches to this. One of them is what we call cap and trade system, where we actually set the total amount of emissions that can be released. That's the stick, if you will. That's the regulation. And then we issue limited number of emission permits based on allowable limits that can be traded among sources, so that a source that can easily spend the money to reduce emissions can get some credits and actually sell them to the company that is having some trouble so that they can still legally emit over what their allowable limit is. I found it interesting in reading a story that Elon Musk promoted carbon credits in China for his plant over there for developing electric vehicles. He's made more money from the credits of emission reductions from his EV production in China than he has from his cars. So, good idea can go a long way. The other is just a pure straight carbon tax. It sets a price on the ton of carbon and allows people to actually reduce that carbon to have a value. It's very similar to a credit system. And we have a global international credit system today. And a lot of companies today that say they are carbon neutral, they're still polluting, but they're getting credits, and they take that as their bottom line. They offset that with credits. Now, whether that's fair or not depends on, I guess, your point of view. More than a dozen different carbon pricing bills have been introduced in Congress in the past few years, and nothing has passed yet. So it really is up to the United States Congress to do something about it. I wanted to mention that the Clean Air Act in 1990, which I mentioned previously, used the cap and trade to successfully cut sulfur dioxide and NOx and nitrogen oxide emissions by 50%. So we know it works. It's just a matter of putting it into practice. We have two existing trading programs today. One is something called the Regional Clean Air Act Incentives Market, which is a cap and trade system that has been used at the South Coastal Air Quality District Management. It has required industries and businesses to cut their emissions by a specific amount, 70% reduction for nitrogen oxides and 60% were received for sulfur dioxide. So it is, again, an example of an operating system that's successful. The other is the Regional Greenhouse Gas Initiative, which is the only one so far that I know of that's actually targeting greenhouse gas emissions. 9 northeastern US states are participating in it. They didn't start out very well. It wasn't binding initially, which made it a lot of loopholes in it. And unfortunately, it hasn't been terribly successful except in the power sector in reducing CO2 emissions. But they have generated $1 billion in revenues for participating states to spend on other kinds of emission reduction efforts. So we've seen the states participating in this have seen their fossil fuel emissions drop by 90% faster than anywhere else in the country. Doesn't mean 90% reduction, 90% faster. That's the rate. So, in conclusion, a word I love to hear, what can we do? What can save us? Well, first of all, public acceptance that is a real crisis. Even though we are experiencing it today, we are going to continue to have days like this, unfortunately, because of the problem. Business-government cooperation is absolutely essential. We cannot do this just with government actions. It takes business too in a cooperative manner. Rapid mitigation of emissions, rapid climate adaptation, stewardship of critical resources, water in particular, thinking of our children and theirs, and a net zero carbon by 2050. That really is the goal of what's going to help make a difference. These are my conclusions. Climate change has occurred naturally since the Earth formed, but human activities have significantly increased the rate of that change. Burning of fossil fuels and use of cement are major causes. Climate change can dramatically change our way of life. Current national and international efforts are so far less than effective. Collaborative efforts are needed with the private sector. Using the market to reduce fossil fuel use is the most effective way. It is a choice we humans have to make. These are some of the acknowledgments of where I took material. So let me see if I can take some questions. Let me see if I can give you some answers.